Now let's talk about the volumetric measurement. Of course, volumetric measurement is the amount of space a substance occupies. When I say the substance, normally the substance comes in liquid form, right? So that's why you need to measure them in volume, not by the weight. Okay, normally in volumetric measurement, a liter is the basic unit in metric system. That's what you're going to use. A liter, milliliter, or microliter will be the range of the measurement you will be performing. So the examples of the volumetric devices are like graduated cylinders. You have seen those before in the lab, right? And volumetric flasks, pipettes, micropipettes. Okay, which of the devices you look at, they normally come with graduation on their body somewhere, right? Graduations is probably the collective lines that show up. Like in this case, these are all graduation. So they should be very accurate graduation, okay, and following the ASTM, American Standard or Technology or some, I don't remember what that stands for. There's an organization that performs and regulates the measuring devices. Okay, so make sure you're dealing with a very accurate volumetric device. When you determine volume using graduation, okay, you need to make sure that what kind of cohesion or adhesion your liquid has, right? If it's water, of course, water molecules have what? Hydrogen bonding. So they typically have cohesion among themselves, and they also have adhesion with the measuring device. So you may see something like that shape made by the top level of your liquid, in this case water. We call that a crescent moon shape surface. We call that meniscus in Greek. Okay, so when you have a meniscus showing up on your measuring device, the question is, where do you measure using your graduation? Do you measure the top, surface of your meniscus or the bottom surface of your meniscus? Of course, the answer is the bottom surface is where your graduation should be parallel to. So that'll be the, the volumetric unit, and you're going to be measuring, in this case, what, about 6.8 milliliter. Okay, so understand the definition of meniscus in your volumetric determination. And then if you're using a pipette, there are two types of different pipettes that you can use. One is called the serological pipettes, and the other one is called Morse pipette. What's the difference? So serological pipettes, if you look at their graduation, it starts from maybe a very tip of the pipette. So that's the start of your measuring volume. Okay, but if you look at the Morse pipette, it doesn't happen that way. So your measurement starts from there all the way up to wherever it ends. Okay, so in the serological pipette, to contain volume within your pipette is same as the to deliver volume. Okay, but in Morse pipette, to contain volume, it may be more than what you're going to deliver. So understand the difference in between. Mostly, you will be using a serological pipette in your lab. Okay. And then there are a whole bunch of volumetric glasswares that you can use. Make sure those are all accurate volumetric devices. And the temperature affects your volumetric measurement, of course, because the thermal energy can expand the volume of your liquid. So that is another important factor. And then beakers and Erlenmeyer flasks, you may see those in the lab a lot, and they do come with graduation on their sides. Okay, but the thing is, they are not considered as volumetric devices because the graduation found from beakers and Erlenmeyer flasks are way off, because they are about 5%, plus minus 5% off in their accuracy. So you don't use beakers or Erlenmeyer flask when you determine the volume of your liquid. So they are containers, not measuring devices. Okay, then what are the real volumetric devices that you can use in your volumetric determination? Those are graduated cylinders, okay, very small tolerance, burettes, okay, volumetric flasks, and then pipettes, okay, and plastic disposable glass reusable pipettes, same way, and the volumetric pipettes. But pressure pipettes are not volumetric devices. Okay, so there are different kinds that you can use. Even the micropipettes are other types of volumetric devices. So speaking of micropipettes, you will be using them a lot because you will have to measure very small volume in your lab. Okay, so when you say normally it's a micropipetter or micropipette, what kind of range does it cover? Normally it covers between 1 and 1000 microliter. You understand 1000 microliter is same as 1 milliliter, right? So the volume that's less than 1 mil is accurately measured by your micropipetter. So there are several different kinds of micropipetters. Each micropipetter comes with different range it can detect. So you need to check what range your micropipetter will measure, and then you have to select the correct one for your measurement. Okay, whichever the micropipetter you'll be using, this is the order of operation. You should understand this. Okay, you need to set up the measured volume you're gonna measure using the rotator knob, and then you will have to place a disposable tip at the end of the pipette barrel. But we do that aseptically because pipette tips come in aseptic condition, contained box. Okay, so you have to open up the box and place the micropipette tip quickly and close the lid of the pipette tip box. Okay, and then press the plunger using your thumb, okay, to the first stop. If you press it with your thumb, you will feel the resistance point. You press the button until that stop point. You don't want to exceed that. And then while your thumb is holding at that first stop, okay, you're going to place your tip below the surface of your solution. So the tip will go under the solution level, and then while you're holding your pipette tip inside of the liquid, you will release your thumb slowly. So when you release your thumb slowly, that button will be released because there's a spring that's coiled up, and the spring is being released now when you depress your thumb. So that's how your liquid will be drawn in through the pipette tip. You want to do that slowly. If you do it too rapid, your liquid will be sucked into the pipette barrel. You don't want that. Okay, so you release your thumb all the way very slowly, and once that's done, the liquid will be taken into the pipette tip to the right capacity, and then transfer the tip, okay, to the receiving end, wherever the container your liquid is going to go in. Transfer the tip to there, and then now put your thumb back on the button and slowly press that button again. Then you will see the ejection of the liquid from the pipette tip to the receiving container. So you will do that slowly until the last drop of the liquid will be dispensed. So in this case, you can exceed the first step to remove the liquid all the way from the pipette tip. Once that's done, release your thumb again, and then you can eject the tip. So that's the order of micropipetter operation. So if you're not familiar with this, practice a few times, understand that. Okay, you don't want to overpress your first stop on your button. That's really important, and you're going to release it slowly. Okay, and how to use your micropipette aseptically, that's also important. Okay, so factors that affect the accuracy of micropipetters. Of course, number one is your technique. Okay, so don't overpress it, or don't depress it too fast, or you release it slowly. Okay, and use your best aseptic technique. And then the physical and chemical property of the liquid matters. If your liquid is so viscous, it's hard to draw in, that'll be a problem, right? And the environmental condition again, maybe too hot, too dry, or maybe there's too much the airflow. Those are not all good. And the condition of the micropipetter, it should be cleaned up and maintained regular basis. Okay. And the contamination problem, like I said, you have to use aseptically. So if you overdraw liquid, not only through the pipette tip, sometimes liquid can get sucked into the pipette barrel. Then that liquid could cross-contaminate with the next liquid you will be measuring using micropipetter. So you try not to do that. Okay. So, and then aerosol could get sucked in, like I said. And let's say you're using your micropipetter to set up your PCR. That could be a big factor. Contamination in your PCR will be amplified, right? So make sure you try not to do that. Okay. Pipette methodically, please read that box 20.4 on your textbook, page 358. Okay. Plan accordingly and label all the tubes, and then whenever you pipette something and change the location of the tube to a different place, you understand which tubes are already pipetted in, which were not pipetted in. So those are all based on experience. You will understand why you need to do that. Okay. And cleaning and maintaining your micropipette, of course, that's important. Any kind of liquid, it is useful. If that liquid it touched your pipette barrel, that's a cross-contamination. You want to make sure that you wipe it up completely using disinfectant solution. Okay, and your plunger can get jammed and damaged. So if that happens, you have to let us know so we can fix that, repair that, and calibrate it. Okay, let's see. And then we can talk about the temperature measurement. I'll stop right here.